Hello everyone. Let us now discuss today's LeetCode POTD problem, 21st December 2024. Question number 2872, maximum number of k divisible components. In this video, I will be explaining you the input, output and the constants. First part will be about the question explanation. So, we are given with n nodes, 0 to n minus 1. And we need to construct, we have given a tree of n nodes from 0 to n minus 1 with edges. Now, these edges are represented of n minus 1. That means these edges are connected like 1, 2, 2, 0 and so on like n minus 1. This is a 2D vector. This is a 2D vector. Now, after that, we are given with the tree, we are given with the values for n. That means we are given values for every node from 0 to n minus 1, where value of I represent the value of the ith node, and this is the values which we are given in an array of size n, and we are given with an integer k. So this k, we need to divide this tree into components where every component is divisible by k. That means if you think like this is a component where it is having 1, 2 and 3 and the k given is 6. Now this component 1 plus 2 plus 3 whole sum is equal to 6. Now 6 is divisible by k. That means 6 is divisible by 6. So this will be one component. Now our target is to return the maximum number of components from this tree. From the tree, we need to return the maximum number of components. Now, the constants are n value. The number of nodes which we are given is 3 into 10 power 4. Values will be 10 power 9. K value will be 10 power 9 up to 10 power 9. And this is an important thing. Sum of values is divisible by k. So, I'll explain you how. Now, let us take a tree. Here, we are having a root node and the children and so on. So here let us assume here this subtree, this is a subtree and this is a node and this another thing and this subtree and these two. These sums are divisible by k. These sums are divisible by k. Let us imagine the sum as 6 and here it is 12. Here it is only one node, here it is 6. We are having 6 and 12 and 6 here and another 24 here, a 42 here. 24 and 42. Let us take like this, and if you add all these elements 6 4s are 24 plus 24 48 plus 42 90 is also divisible by k. So that means let us assume we only took this 6. So only this node, we unconnected this from the tree. So if you remove that 2, this sum is also divisible by k. That means our approach, I will be telling you the approach in next few seconds. For some time, forget the hints and the examples given in the description. Let us go with a tree. I'll be giving you an example. So, I am representing only the values, not the nodes. I am not representing the nodes. I am representing the value for every node. For this node it is 1 and for this node it is 5, 7, 5, 6, 0, 3, 2, 1, 6 and 6. Important thing is Sum of all values is divisible by k. So let us go with this one. As I said, all this is divisible by k. So here it is 6. Here it is 6, and let us assume all this has the sum of y. Now, is it divisible by k? Is it divisible by 6? Absolutely yes. Because if x plus y is divisible by k, then individual x is divisible by k and y is also divisible by k. Even if you remove this component and assume, let us assume all this as an individual component, then it is also divisible by k. So there is no worries about removing this connection from the tree. As I said, they want the maximum components from the tree. So let us go with this example. Now 6 is this up to here. I am taking the sum of the subtree. Up to here, there is no children for this node. Now this prefix sum. So next sum or prefix sum will be 6. So as I said, we need maximum components. Let us take this as a component. No. Is this divisible by 6? Yes. That's why we have divided a component. Now, here, it is divisible by 6. Let us unconnect. Now, there is no children for this one because we have unconnected. We have removed the connection from this node. So, for this, the prefix sum, the down sum will be I will be passing if I remove the connection only 0. For this also is 0. Now what is the prefix sum for this one? 1. I am coming from the end. From the end. Now 1 has no prefix sum and it is not also divisible by 6. Now I'll be giving 1 and then I will be giving 5. Here also I will be giving 7. Here also I will be giving 5. And if this value is divisible by 6, I will be removing the connection. So wait, we got 1 and we got 5. This value will be 6 now. And here we got 5, we have 7. This value will be 6 plus 5, 11 plus 7, it will be 18. Now we have 18 and we have 6. What does this indicate? This is a component. The previous values are 6, 7 and 5. So if you add this all, 6 plus 5, 11 plus 7, 18. So we are taking the prefix sum or the down sum or the child sums for every node. And if it is divisible by 6, then remove the connection. If it is not divisible, send the prefix sum. If it is divisible, send 0 as the prefix sum. Now we got 0. Now this is another one. We got 6 as the prefix sum. So it is divisible by 6. Now remove the connection and send 0 as the prefix sum. Here we got 0. Here we got 3 plus 0 will be 3. And here we got 1. We will be sending 1, we will be sending 3, and 2 plus 1 plus 3 is equal to 6. It is also divisible by 6. So this will be another component. I think it is quite clumsy there. I'll be giving you another one, drawing another one. Now, here we are having 1, 5, 7, 5, 0632166. This is a component, this is a component, and we will be sending 0 here, we will be sending 0 here. Now 1, sorry, we will be coming from the end. As I said, 1 plus 5 will be sending 1, we will be sending 5, here it will be 6. So this is a component, we will be removing the connection. 7, we will be sending 7, 5, and 7 plus 5, it is 12 plus 6, it is 18. Now it is divisible by 6, so remove the connection. Now this is a component, this is a component, this is another component, this is another component, and send 1, it is not divisible by k. Send 3 is not divisible by k. 3 plus 1, 4 plus 2, it is 6. So this is another component. 1, 2, 3, 4, 5. We have 5 components for this tree. So it is as simple as that. It is over. Up to now, it is completed. So the problem here is how we'll be doing this such. That means, as I said, constraints are important. Don't neglect them. Here, prefix sum for every node will be considering. Consider prefix sum for every node. If the prefix sum is divisible by k, if the prefix sum is divisible by k, then the number of components, they only asked us about the components, then increment our answer and we'll be returning 0 as a prefix sum. Else if it is not, then we'll be returning prefix sum. So this will be in our DFS algorithm. As I said, we'll be coming to the end and going through. We'll be sending the prefix sum or 0 if this is divisible by k. So we'll be sending the prefix sum or 0 if it is divisible by k, we'll be returning 0. Else we'll be returning our prefix sum. So the df, and as I said, constant about the constants, prefix sum may increase in the maximum limit of integers. So we'll be initializing long. So our dfs will be having long returning type. So you will be getting the code. This is as simple as that. You will be getting the code. If you like this video, share to your friends and subscribe to my channel. This will be helpful for me, and I'll be doing the POTD for LeetCode every day. You can follow me in Insta, LinkedIn, and other platforms. Thank you.